Now we need to talk about the driving forces that move these ions across the membrane. So we're going to talk about three different ions here. We're going to talk about sodium ions in green. We're talking about chloride ions in this yellowish color. And potassium ions, this triangle orangish color. Potassium has a positive charge. Chloride has a negative charge. Sodium has a positive charge. Now, you may have heard that we are made up of salt water, and salt is sodium chloride. So it shouldn't surprise you that most of our cells are bathed in a mixture of sodium and chloride. So we always have a lot of sodium and chloride on the outside of our cells. With less simple of an explanation, we have a lot of potassium on the inside of the cell. So there's more potassium on the inside of the cell, and there's more sodium on the outside of the cell. Okay? So we have two driving forces. One is electrical, one is chemical. Let's start with the chemical first. So simple diffusion. If I open up a channel across this membrane and I have more sodium on the outside than on the inside, sodium is going to want to move into the cell. If I open up a channel just for potassium, okay, there's more potassium on the inside than outside, so according to simple diffusion, potassium will want to move out of the cell. If I open up a channel just for chloride, there's more chloride on the outside, chloride will want to come into the cell. Okay, that's called the chemical or concentration gradient. Sodium in, chloride in, potassium out. The other driving force that moves these ions is their charge. It turns out there are more electrical charges lined up on the inside of the cell. And we know that positives and negatives attract to each other, and the same charges repel each other. So positives will move toward negatives, okay, and negatives against negatives, positives against positives. So since we have these positive sodiums outside and it's more negative on the inside, sodium will also have an electrical driving force to move in because it's positive and the inside is negative. Chloride will not have an electrical driving force to move in because there's more negatives on the inside and it's negative on the outside. It's going to want to stay right where it is based on the electrical gradient alone. Turns out the chemical gradient is stronger and chloride will still move in. But sodium has a double whammy. It has both electrical and chemical driving force for it to move into the cell. What about potassium? Well, potassium is positive. It's more positive on the outside. It's not going to want to go anywhere either. So according to the electrical gradient, potassium is going to want to stay right where it is too. So sodium has both a electrical and a chemical driving force to move into the cell. Chloride only has a chemical driving force to move into the cell. And potassium only has a chemical driving force to move out of the cell. That leads us to our ion flow mantra of sodium in, potassium out. Sodium in, potassium out. Get comfortable with it because if you mess this up on the quiz or exam, you're going to lose a lot of points. Okay, this is how the ions move across the membrane during an action potential.